Assalamu alaikum warahmatullahi wabarakatuh. Welcome back. Part 2, Lesson 3 in Chemical Equation. Part 2 is about our objective today is to know the state symbols used in chemical equations and also how to identify balanced and unbalanced equation. This is the main point today. The new words, of course, it's not a new state, solid, liquid, gas, aqueous solution, and balanced. A symbolic representation, this is the meaning of chemical equation. It's a symbolic representation of the reactants and the products. An arrow separates the reactants and the products. How to represent the physical states of reactants and products. If it is a solid substance, we write S. If it is liquid, we write L. G for gas, AQ for aqueous solution. And we have said that aqueous solution, like when salt dissolves in water, so it is salt solution. Salt solution, how can I write it? NaCl, salt solution, NaCl, and here AQ, aqueous solution, AQ. This means NaCl is dissolving in water, so it is salt solution. Upright arrow means gas produced. Downward arrow means precipitate. Right arrow means direction of the reaction. And a triangle means heat is needed. Heat is needed.
Magnesium metal reacts with hydrochloric acid to produce hydrogen gas and dissolved magnesium. We can test the presence of hydrogen gas by placing a lit splint at the mouth of a test tube. If we hear this distinctive squeaky pop, it means that hydrogen has indeed been produced. The unbalanced equation for this reaction looks like this. In another lesson on this channel, we learnt about balancing chemical equations. Can you try balancing this equation yourself? Grab a pencil and a piece of paper, pause the lesson, and resume when you are ready. Because atoms are never created or destroyed during chemical change, only rearranged, the number of atoms for each element on the reactant side must be equal to the number of atoms for each element on the product side. So the balanced equation will look like this. As there are 2 chlorine atoms on the product side, there must also be 2 chlorine atoms on the reactant side. You can also see that the number of hydrogen atoms is also balanced because there are 2 hydrogens in the hydrochloric acid on the reactant side, and there are 2 hydrogens on the product side. Now, we are not quite done with this chemical equation. For this equation to be complete, we must also include the state symbol for each reactant and product. There are 4 possible states, each with their own unique state symbol. Solid, represented by lowercase s. Liquid, represented by lowercase l. Gas, represented by lowercase g. And aqueous, or dissolved in water, represented by lowercase aq. This is written after each reactant or product in brackets and in subscript, meaning a bit lower than the actual text. As magnesium metal is solid, we represent this state with lowercase s in brackets, in subscript right after the symbol. Hydrogen gas has a state symbol G because it is a gas. Note that hydrochloric acid is in fact hydrogen chloride dissolved in water. So it has a state symbol AQ, much like dissolved magnesium chloride. Remember that squeaky pop described at the start of the lesson? This is in fact the reaction of hydrogen gas with oxygen in air to produce liquid water that you can observe at the mouth of a reaction vessel. Since we have learnt about state symbols, why not try the following? Write the chemical equation for the above reaction, balance it, and add state symbols for each reactant and product. Pause the lesson and resume when you are ready. Hydrogen gas reacts with oxygen to produce water. As hydrogen and oxygen are a diatomic gas, we must also represent that in the equation. Balancing the equation gives us. Adding the state symbols completes the equation. In summary, state symbols represent each of the reactant and each product in reaction, and must be included in every chemical equation.
Now, why we balance a chemical equation? Why really we need to balance a chemical equation? Of course, because to maintain the law of conservation of mass. To maintain the law of conservation of mass, in which when balancing chemical equation we never change the subscript, only change the coefficient. Only change the coefficient number.
Let's have a go at balancing an equation. Sodium hydroxide is a soluble salt, but most other hydroxides are insoluble. They can be made by reacting with sodium hydroxide, like this. A good way to balance an equation is to use a table to keep track of everything. You can list the number of each atom on the left-hand side and the right-hand side of the equation, then compare to see if they are the same. Remember, you can only change the big number in front of compounds, which says how many molecules you have. You can't break up bonds to make it balance. Try filling in this table now. Pause the video whilst you add up the atoms. Are you ready? These are the numbers you should have found. We can see that the metals are balanced, but there are 3 times as many chlorine atoms on the left and 3 times as many oxygen and hydrogen atoms on the right. So let's multiply the compound containing chlorine on the right by 3 and the compound containing hydroxide on the left by 3. Is it balanced? Pause the video whilst you fill in the table again. What do you get? The equation is now balanced. Let's look.
Here is an example for how to know this equation is balanced or not. Let's check the left side, which is the reactants. We have carbon and oxygen here in the left side, here in the right side, for the same atoms. Carbon, before the reaction, in the reactants it's 1, and in the products also 1, so they are equal. For oxygen, in the left side, reactants side, before the arrow we have 2 oxygen atoms, and after the arrow in the products we have also 2 oxygen. So this equation is balanced. This equation is balanced. Here let's see an equation. We have only 2 atoms, hydrogen and oxygen. Before the reaction, in the reactants, before the arrow, those here, this side is the reactant side, reactant, and here after the arrow it is the products. So how many hydrogen atoms before the reaction? When you have 2 hydrogen atoms, and after also 2. But in the oxygen we have 2 in the reactants and 1 in the product, so they are not equal, which means this equation is unbalanced. This equation is unbalanced. How can we balance this equation? We have to multiply the oxygen with 2. So 1 multiplied by 2 equals 2. So here we have 2 oxygen atoms, and here we have 2 oxygen atoms. So the oxygen is balanced. But once we change the oxygen here and put it here as a coefficient, now also the hydrogen is changed in the product. So 2 multiplied by 2 for hydrogen. So hydrogen becomes 4 hydrogen atom. 4 hydrogen atom. Now how to balance it? We must also multiply the reactants, the hydrogen, with 2. So 2 multiplied by 2 also equals 4. Now the equation is balanced. We added 2 numbers here. In the reactant we wrote 2, and in the products we wrote also 2 in the water molecule and in the hydrogen molecule. So all of them are balanced. All of them are balanced. How did we do this? Again, as you can see, first step you have to balance oxygen here. We have 2 oxygen atoms, so it's alright. And in the right side, which is products, we have only 1. 1 multiplied by 2 in total equals 2. Directly take these 2 and put it here in the equation as a coefficient number. Now by writing 2 as a coefficient number, this number, did it change the oxygen only or oxygen and hydrogen? Of course it changes both of them, hydrogen and oxygen. So this number also will be multiplied for hydrogen. 2 multiplied by 2 equals 4. Now we must make for hydrogen in the reactants and in the products, we must make them equal. How? By multiplying the reactants with 2. 2 multiplied by 2 equals 4. So 4 in the reactants, 4 in the products. This 2 will take it directly and write it here as a coefficient number. Another equation, Mg plus O2 equals MgO, or produces MgO. Now how many magnesium atoms before the reaction? 1. After the reaction in the products also 1, so it is correct, they are equal. But for oxygen atom we have 2 oxygen atom in the reactants and only 1 in the products, so they are not equal. It's unbalanced equation. How to balance this equation? Directly, as we said, we try to make the oxygen equal. How? By multiplying 1 multiplied by 2 equals in total 2. So this number, we will take it and write it here as a coefficient number. Alright, then by adding 2 as a coefficient number here in MgO in the products, these 2, is it a change only magnesium or oxygen and magnesium? Of course it changes both of them, magnesium and oxygen. So we must multiply magnesium with 2. So in total we will have here 4 magnesium atoms. This forces us to also multiply the left side, which is the reactants, with 2. So 2 multiplied by 2 equals 4. They are equal. As you can see, they are equal. So Take this 2 and put it here as a coefficient number. It's very easy. Now it is balanced. We have 4 magnesium atom and 4 magnesium atom in the reaction and the products. For oxygen, sorry, this one is wrong. Supposed to be here magnesium. Now it is balanced. This one is another example of balanced equations. Check that you understand why they are balanced. Check why they are balanced. For this question we have Cu, we have copper and carbon and oxygen. In the reactants how many? And in the products how many? In the reactants we have 1, in the products also we have 1. For carbon, how many carbon atom in the reactants? Here, as you can see, this is the copper, this is the carbon. Carbon we have only 1. And in the product C also we have 1. So carbon atoms, they also are equal. Now last, for the oxygen. In the reactants we have 3 oxygen atoms. It's okay, 3 oxygen atoms. In the products we have, here we have 1 oxygen atom and here we have 2. So we have 1 plus this one, plus 2 equals 3. So copper 1 1, they are equal. Carbon 1 1, they are equal. Oxygen 3 3, they are equal. That's why this equation is a balanced equation. Try to solve this one. Check that you understand why they are balanced. Thank you all. I hope you understood this lesson. Goodbye.